For optimal performance and longevity in electrical conduit connections, consider compression couplings made of malleable iron. These couplings provide a superior balance of durability, reliability, and ease of installation. Malleable iron offers excellent strength and corrosion resistance, making it suitable for demanding applications where longevity is crucial. Compression couplings create a secure, vibration-resistant connection by compressing a gasket against the tubing, ensuring a tight seal that resists loosening over time. These couplings are relatively easy to install, requiring only a wrench to tighten the compression nut, simplifying the installation process and reducing labor costs. While set screw couplings are a less expensive alternative, they are also less secure and can potentially damage the tubing if over-tightened, making them a less desirable choice for critical applications. Steel couplings are strong and durable, but they are heavier and more expensive than other options, potentially increasing material and installation costs without a significant increase in performance. Die-cast zinc couplings are lightweight and economical, but they lack the strength and corrosion resistance of malleable iron, making them unsuitable for harsh environments or applications requiring long-term reliability. When selecting EMT couplings, ensure that the coupling material is compatible with the tubing material, whether it is steel, copper, or polyvinyl chloride. Selecting a coupling with a pressure rating that meets or exceeds the expected operating pressure is crucial for safety and performance. Always consider the operating environment, including temperature, humidity, and vibrations when choosing a coupling to ensure it can withstand the conditions it will be exposed to. Compression couplings in malleable iron offer the best balance of quality and cost, making them a suitable choice for most applications where performance and longevity are important. Therefore, the order of best choice is firstly, compression coupling in malleable iron, secondly, steel couplings, thirdly, die-casting couplings, and lastly, set screw couplings. Additional considerations include the tubing material, pressure rating, and environmental conditions. For tubing material, ensure that the coupling is compatible with the tubing material. Select a coupling with a pressure rating that meets or exceeds the expected operating pressure. Consider the operating environment when choosing a coupling. Factors include, but are not limited to, temperature, humidity, and vibrations. When it comes to selecting electrical metallic tubing, or EMT couplings, several factors should be considered to ensure a reliable and long-lasting electrical system. Understanding the different types of couplings available, their material properties, and installation methods will help in making an informed decision that balances cost and quality. Electrical metallic tubing, or EMT, is a thin-walled conduit commonly used to protect electrical wiring. Couplings are used to connect sections of EMT together, providing a continuous raceway for the wires. The primary function of a coupling is to maintain a secure and electrically continuous connection between the EMT sections. This ensures that the wiring is protected from physical damage and environmental factors, while also providing a path for grounding, which is essential for electrical safety. There are several types of EMT couplings available, each with its own advantages and disadvantages. The main types include set screw couplings and compression couplings. Additionally, these couplings are available in different materials such as steel, die-casting, and malleable iron. Set screw couplings are one of the most common and economical types of EMT couplings. They work by using one or more set screws to mechanically grip the EMT. When the set screws are tightened, they create a firm hold on the conduit, securing the connection. Set screw couplings are relatively easy to install, requiring only a screwdriver or wrench to tighten the screws. However, they can be less reliable than other types of couplings, especially in environments with vibration or frequent mechanical stress. The set screws can loosen over time, leading to a loss of electrical continuity and potentially compromising the protection of the wiring. Compression couplings, on the other hand, provide a more secure and reliable connection. These couplings use a compression nut that, when tightened, compresses a ring or sleeve around the EMT. This creates a tight seal and a strong mechanical connection. Compression couplings are more resistant to vibration and mechanical stress than set screw couplings, making them a better choice for demanding applications. Although they are generally more expensive and may require additional tools for installation, the added reliability often justifies the cost. The choice of material for EMT couplings is also critical, as it affects the durability, corrosion resistance, and overall performance of the connection. The most common materials are steel, die-cast zinc, and malleable iron. Steel couplings are known for their strength and durability. They provide excellent mechanical protection and are suitable for applications where the conduit is exposed to physical stress or impact. Steel couplings are also resistant to corrosion, especially when they are galvanized or otherwise coated. However, steel couplings can be heavier and more expensive than other options, which may be a consideration in large-scale projects. Die-cast zinc couplings are a lightweight and cost-effective alternative to steel. Zinc couplings offer good corrosion resistance in many environments and are suitable for indoor applications or areas with mild environmental conditions. However, they are not as strong as steel or malleable iron and may not be appropriate for applications where the conduit is subject to significant physical stress or vibration. Malleable iron couplings provide an excellent balance of strength, durability, and corrosion resistance. Malleable iron is a type of iron that has been heat-treated to increase its toughness and ductility. This makes it more resistant to cracking and breaking under stress compared to standard cast iron. Malleable iron couplings are a good choice for both indoor and outdoor applications, especially in environments where the conduit is exposed to moisture, chemicals, or mechanical stress. While they may be more expensive than die-cast zinc couplings, the added durability and reliability often make them a worthwhile investment. When specifying EMT couplings for a project, it is important to consider several factors to ensure the best possible outcome. These factors include the environment, the type of wiring being protected, and the overall budget. In demanding environments, such as industrial facilities or outdoor installations, malleable iron compression couplings are generally the best choice. These couplings provide the highest level of protection against physical damage, corrosion, and vibration, ensuring a long-lasting and reliable electrical system. While they may be more expensive upfront, the reduced maintenance and replacement costs over the life of the system can often offset the initial investment. For indoor applications in less demanding environments, steel or die-cast zinc couplings may be acceptable. However, it is still important to consider the potential for corrosion and mechanical stress. Steel couplings provide excellent strength and are a good choice for areas where the conduit is likely to be subject to physical impact. Die-cast zinc couplings are more suitable for areas where weight and cost are a primary concern, as long as the environment is relatively mild and there is little risk of physical damage. Set screw couplings should generally be avoided in critical applications due to their lower reliability. However, they may be acceptable for temporary installations or in areas where the risk of loosening is minimal. If set screw couplings are used, it is important to regularly inspect and tighten the screws to ensure a secure connection. Regardless of the type of coupling chosen, proper installation is essential for ensuring a reliable electrical system. All couplings should be installed according to the manufacturer's instructions and relevant electrical codes. This includes properly preparing the EMT, tightening the couplings to the correct torque, and ensuring that all connections are clean and free of corrosion. In addition to the type and material of the couplings, it is also important to consider the size and type of EMT being used. The couplings should be compatible with the EMT in terms of size and material. Using the wrong size or type of coupling can compromise the integrity of the connection and potentially create a safety hazard. Finally, it is important to document all coupling specifications and installation procedures for future reference. This will help with maintenance and troubleshooting and ensure that the electrical system remains safe and reliable over time. In summary, selecting the right EMT couplings involves considering a variety of factors, including the environment, the type of wiring being protected, and the overall budget. Malleable iron compression couplings are generally the best choice for demanding applications due to their superior strength, durability, and corrosion resistance. However, steel or die-cast zinc couplings may be acceptable for less critical applications. Regardless of the type of coupling chosen, proper installation and maintenance are essential for ensuring a reliable and safe electrical system. When making a final decision, it is crucial to evaluate the specific needs of the project and weigh the cost against the potential benefits of each type of coupling. In situations where reliability and longevity are paramount, investing in higher quality couplings is often the most cost-effective approach in the long run. Firstly, consider the environment where the EMT will be installed. Secondly, think about the type of wiring that will be run through the EMT. Thirdly, consider the budget for the project and balance cost with quality. Finally, ensure that all couplings are installed according to the manufacturer's instructions and electrical codes.